This week on Maker Update, Pawn takes a walk, a manual controlled pick and place machine, a brain you can program, and wearing your 3D prints. Hello and welcome back to Maker Update, our weekly opportunity to share with you all of our favorite Maker projects, tips, and tools from across the internet. I'm Tyler Weingartner, and I hope your summer is off to a great start. We've got a fun show for you. Let's get started with the project of the week. What is it about the game of chess that activates the minds of makers? Whether it's Works by Design's transforming chess pieces or this LED glowing chessboard, it's been a fertile ground for projects for some time. But I love the ingenuity of 3D Printed Life's robotic chess pieces, where each piece can move itself across the board. And yes, there are boards with a hidden magnetic gantry to move the pieces, or a robotic helper to move the pieces for you. But this isn't that. Each piece is its own self-driving robot. Which means that there's a whole lot jammed into each piece. A PCB with an ESP32 microcontroller, 2 stepper drivers, a sensor for magnetic fields, 2 tiny stepper motors, and a battery. These tiny stepper motors were a real revelation for me. I knew that you could get stepper motors in just about any size, and intellectually I knew that photographic equipment and other devices depend on precise control from motors that are very small, but economies of scale have made these teeny tiny steppers easy to source and fairly cheap to buy. But that's just one part of the puzzle, because those motors don't really do much good unless the piece knows where it is and where it needs to go. He does experiment a bit with creating a remote controller for his chess piece, but it's just an experiment. He's using an arrangement of electromagnets hidden underneath the board, and the magnetic sensor on the PCB uses those magnetic fields to find its way around. To keep everything in sync across all the pieces, he's using messages sent via the ESP-NOW protocol. This is an ongoing project. He still needs to build the rest of the pieces, a whole lot more electromagnets, and then work out the pathing of all 32 pieces on the board at once. But there's a ton of great stuff already in this video, from the clever way the piece navigates the board, to those tiny stepper motors, making the piece able to move on its own. It's also a very funny video, when humor doesn't always elevate videos about complex systems. All of his work on this project is open source. You can check out the Git repo for the project by following the links down in the description. More projects. The allure of surface mount PCBs is hard to resist. The scale of components has gotten so small that even your own DIY projects can be tiny. But without a steady hand, soldering these boards can be a nightmare. Which is why MagmaBow created this tiny DIY pick-and-place machine for less than $200. And it's impressive just how scrappy this machine is. While he experimented with making his own analog control board, he actually just harvested the control board from a retired Ultimaker 3D printer. Most of the cost goes into the motors, the extrusion, and the suction grabbers. But what really struck me about this project is that this isn't a CNC machine. Everything is controlled by this dual twin-stick custom controller. At first blush, this almost feels like a half-finished project. But if you've ever worked with tiny surface mount components, you know how easily one errant motion of your hand can ruin your whole day. This lets you use the robot as your steady hand while still keeping you involved. It's a great workaround that fits into a fairly unique but useful tool niche. From the Ruiz brothers, we have a brand new take on a classic handheld game, Bop-it, but this one is called Prop-it. Like the original game, it has a number of interactions, and the game will call it which one it wants you to do. Flip a switch, slide the slider, push a button, spin this thumb wheel, or give the whole thing a shake. The longer you play, the more the game speeds up, with a countdown playing across this shrinking LED strip. The Prop-it name comes from the Adafruit Feather RP2040 prop maker board that's controlling everything. With the onboard amplifier, accelerometer, and dedicated NeoPixel circuit, this is pretty much all you need. The display is a 14-segment module connected via stemma QT, and the rotation of the wheel is detected using a Hall effect sensor and some magnets. The body is all 3D printed with a lovely, retro-inspired, chunky look. Looks like a great project to make and share with friends. Also from Adafruit are these Dragon Kite Poi that light up with WLED, created by Erin St. Blaine. She started off with these pre-made dragon tails and heads that are already ideal for poi spinning. Hers are 6 meters long, but she recommends starting with 4 or 5 meters, just because they're easier to manage. To keep things lightweight, she's using these NeoPixel Pebble seed strands for the lighting and controlling them using a mini sparkle motion board. She uses a wide zigzag stitch to attach the NeoPixels and glues the board and the battery into the head. It's a gorgeous project that looks spectacular at night, especially with the audio reactive WLED presets. Now for a few tips and tools, Becky Stern has a new video about the Spikerbot by Backyard Brains. This is a robot kit you can program using neurons instead of code, and I'll admit, I'm not quite sure I'm fully getting my head around this. But it's an alternate means of coding to help you understand why brains are so different from computers. You can program it to recognize a color and move towards it with just 2 neurons, something that would take dozens of lines of code. But apparently getting it to count will take a whole lot more neurons, even though that would be a pretty minimal amount of code. It seems like a fun kit, and it's great to see Becky put it through its paces. benchforma has a quick and easy tip on how to add texture to the top layer of your 3D print, using tools that can be found in your slicer. Basically, all you do is add an additional surface to the top of your print and use your infill settings to adjust the pattern. This can be done with a single color print, or you can swap colors for a more striking contrast. He also shares another technique for adding texture to the sides using Autodesk Fusion and CNC Kitchen's Bump Mesh module. From 3D Printland, I learned about a technique that allows you to 3D print your own iron-on designs using flexible TPU filament. Apparently this technique has been around for a few years, but it was new to me. You create the design and print it in a thin layer, then apply it to your fabric. And then using a thin Teflon baking sheet, you use a clothes iron to melt the design into the fibers of the shirt. The surprise is that these can hold up to multiple wash cycles. Maybe not as many as your Iron Maiden shirt from the 2004 tour, but better than you'd expect. And in a recent video, Diresta shares some of his tips he's developed over the years for using CNC routers. He covers everything from making small drawings of your bit radius to see how well it fits into the corners of your design, how to keep your spoil board pristine for as long as possible, and the benefits of having a zero plate with a few different levels cut into it, just in case you want to cut a little bit deeper than normal. And I love this quick tip of writing the word tight on your collet wrench to remind you which direction to turn it if you're not used to working upside down. For this week's DigiKey Spotlight, Zach, the Byte-Sized engineer, is building a whole home energy monitoring system using current transformers. If you want to reduce your energy bill, you need more localized reporting on how much each room is using, and you need moment-to-moment information, not once a month. These current transformers clamp around each of the hot lines in your circuit breaker panel, though they will need a simple custom circuit before the microcontroller can read the signal. He's able to monitor everything on the ESP32 via Home Assistant, and after a bit of calibration, he's got a DIY home energy monitoring solution. It's good stuff. All right, and that is going to do it for this week's show. I hope you enjoyed it. A reminder, as always, that you can get more info about every single one of these projects by following the links down in the description. While you're there, leave us a comment, give us a thumbs up, and hit subscribe so you won't miss the next one. Huge thanks, as always, to DigiKey for making this show possible and to you for watching. Take care. We'll see you soon.